Okay, well today's lesson is going to be about fractions. Now today's lesson we're going to go... Okay, so the first thing we're going to say is proper fractions. Now proper fractions are probably the most common fraction that you'll see. Proper fractions are fractions in which the denominator, this one here, oops, why is it a lightsaber? I have no idea. Let's change it back to something different. Okay, the numerator, the top one, is smaller than the bottom one. Now let's go over again what they mean. So the numerator is the top one, and this would let's start with the denominator. The denominator is the bottom one, and the denominator means how many parts there are altogether. So if you had a shape, let's draw a shape now. If you had a shape and it was cut into 4 pieces, the denominator is going to be 4 because that's how many parts there are all together. And the numerator is how many parts you have. So if you ate 3 pieces of this pizza, your numerator would be this one because it's how many parts you have. So that's pretty basic, but the main thing about proper fractions is the numerator has to be smaller than the denominator. So you can't have a whole shape or a whole object to be a proper fraction. The main reason we're doing this today is because improper fractions. Now, improper fractions are a little bit different. With an improper fraction, you'll see here the numerator is actually bigger than the denominator. So this would come about, so if you had this picture here and you had here someone had eaten 2 halves, so they had 1 half and another half, and then someone had another half. So if you look at how many halves there are altogether, someone's actually eaten 3 halves, okay? They've actually eaten 3 halves. Do you know what I mean? So one person had 1 half, another person had another half, and another person had another half. So it ends up being more than one, actually being is 3 halves. But that doesn't actually make sense because the number on top is actually bigger, which makes it an improper fraction. So what you'll see is most people, when they write that, instead of writing 3/2, they'll write that you ate 1.5, which makes more sense. And I understand that, but that's what an improper fraction is. So the difference between a proper fraction and an improper fraction is that with a proper fraction, the numerator is smaller because you don't yet have a whole. With an improper fraction, the numerator is bigger than the denominator. So we're going to go through and show you how to transfer those back to being a proper fraction and vice versa. So if you had a fraction like 8/5, that is an improper fraction because the numerator is bigger than the denominator. So what we want to do is we want to change that to a whole, back to a proper fraction so that it makes sense. Because 8/5 is not really something that really sounds that good. So the first thing you got to check is how many times does the denominator, this one, fit into the numerator. Okay? So how many times can we fit 5 into 8? You may have to, with bigger numbers, actually do it like this. Now, you don't have to do it with this because it's such a small number, because I know that 5 will fit into 8 1 times. Okay, so that's how many whole I have down. Okay, that's how many whole I have. Now, the second one is how much is left over once I put the 5 into the 8. So once I took away that, you realize there's 3 left. Okay, so there's 3. How many is left over? 3. And the denominator always stays the same. It should always be 5. I know that was really confusing how I just did that, and I'm going to slow it down now and show you how I would do it in a bit of an easy way, and we'll do it a few times. So, 14/5. Remember, the first step was how many times does this fit into 15? Now, if you know it off the top of your head, you'll know that 4 3s are 12, but if you needed to count by 4s and say 4, 8, 12, 16, now you've gone too far, so it doesn't fit in 4 times. 4, 8, 12, it fits in there 3 times. So you put 3 there because that's how many whole times it fit in there, 3 whole times. Okay, so 4, 8, 12. Once it got up to 12, how many more do you need to get to 15? Well, 15 take away 12 means you had 3 left over. And obviously the denominator always stays the same. Okay, let's go through that a little bit clearer now, and I'll write down how I would solve it as I go. Okay, so the first thing is how many times does 2 fit into 22? Now I know 2 times 9 is 18, 2 times 10 is 20, 2 times 11 is 22, so it was 10. So 2, if you didn't want to do it that way, you could do it like this. You could write it down. Okay, I'm happy with that. So you could say 2 goes into 2. Sorry, 2 goes into 20. Sorry, 2 goes into 2 once. Okay. 2 goes into 1 0 times with 1 left over. 10 remained of 1. So you'll see that it went in 10 times. So it's got 10 whole numbers. And how much was left over? 1. 1 over 2. All right, let's try that again. If it's 18 over 5, we can write down 5 into 18. How many times does 5 go into 1? 0. How many times does 5 go into 18? 3 times with 3 left over. Okay, so remember, the first number is how many times does 5 go into 18? It would be 3. And how many left over? 3 into 5. So it's 3 3/5. That's how we convert it. Now, I'm not sure if that was confusing for you. Okay, so I'm going to write down a question now. And see if you can solve it. Pause it and solve it without me, and then we'll go through. Okay, so let's write down a question together. 12 over 5. All right, I'm going to get you to pause your screen now. I'll give you 5 seconds to pause it, and then come back once you finish this question. Okay. Okay, hopefully you've given this a go. Okay, so remember, the main thing is to remember how many times does this 5 fit into the 12, and then how many were left over would be numerator. So how many times does 5 fit into 12? Do you need to write it down? I mean, I don't really need to write it down, but let's give it a go. 5 into 1 goes 0. 5 into 12 goes 2 with 2 left over. So how many times did 5 go into 12? 2. How many were left over? 2. And the denominator always stays the same. So it becomes 2 2/5. If we put an extension question in there just for some people. Now remember, these sort of questions I put in here are not always easy. It's only just to test a few people out. We'll just see how we go with it. Let's see if I had 48 over 3. Okay, and I want to change that back to a mixed numeral. Okay, you put the 3 into 48. How many times does 3 go into 4? Once, with 1 left over. How many times does 3 go into 18? 3 times 5, it goes in perfectly 16 times, doesn't it? Yep, 16. So your answer ends up being just 16 with no extras. It's just 16 whole. All right? Hopefully you've got that. Now we're going to go and talk to you about the other way, how to change these back to an improper fraction. Okay, so a mixed fraction, a mixed fraction is basically what we've been writing, where you've got your whole number here, and then you've got a fraction after it. So you had 2 4/5. Okay, this is quite a common way of writing things, but I want you to know how to change these back into an improper fraction where you would be writing 14 over 5. I know that seems confusing now, but we'll go through some of the steps you would need to do this, and hopefully it'll make a bit more sense, okay? So, remember, a mixed fraction is when you've got the whole number, it contains a whole number and a fraction. Okay, so the difference between the mixed fraction, which looks like the whole number, and the fraction there, and the improper fraction is that with an improper fraction, the numerator is bigger than the denominator. So, let's look at how you solve a mixed fraction. Get mad. Okay, I found this online, and I think it's actually quite a useful strategy to do. So get mad stands for multiply the denominator and the whole number, and then add on the numerator, and the denominator always stays the same. So let's give it a go. When you're doing anything like this, I would always put there. Start from the bottom and then put a times and then a plus at the top. Okay, this will always start with a times. So you're working from this way. You're working around to find the answer. Okay, so picture it like a clockwise. You start from the bottom, you go there, go around, and then your answer comes out here. So you times and then plus. Okay, so you're multiplying the denominator and the whole number, and then you're plussing on the numerator, and then you're going to write that down over here. Let's give it a go. Okay, so 5 times 3 is 15, and then plus 2 is 17. And we said the numerator is going to stay the same, so it becomes 17 over 5. Okay, it's not really that hard. It's just remembering where to put things, okay? So remember, if you're talking about getting mad, the M says multiplication, which always means it goes first. So if we're going into this direction, you should be multiplying first before you do anything else. Let's try some examples. Okay, so let's try this in an example. Straight away, I'm going to put my mad, so multiply, add, and I'm going to keep my denominator the same. So I've got mad. Multiply, add, denominator stays the same. If I've done that, it really shouldn't be that hard for me to do from now on. Okay, so I'm going to work in a clockwise fashion like that. Okay, 4 times 5 is 20. Plussing the 2 there becomes 22 over 4. Okay, so that's your improper fraction, which is, they're the exact same thing. They're the exact same number. Let's give some examples, and we might get you to pause some of them and see how you go with them. Okay, so you see I've written here a year 5 list here over this side, and I've written a year 6 list over this side. They're not that much different. Some of them just get a little bit harder as they go. So what I might get you to do is, I might get you to pause it and solve all of them on your side, whether you're year 5 or year 6 student. And then when you're finished, I'll get you to unpause it and we'll go through them together, okay? So you can pause it now. Okay, so even if you weren't really sure and you think you might have gotten it wrong, that doesn't really matter. We're going to go through it together and hopefully you'll learn as we go. So what I'm going to do before we start is I'm going to go through and add in all the things that I need when I'm adding my multiplication, my add, and the denominators the whole way across, just to make sure that I'm not going to make any mistakes when we get to it. Here, multiply, add. My multiplying and adding looks exactly the same. Maybe I should learn how to draw a little bit better. Okay. Now that I've done that, now we can start. Okay. So 4 times 3 is 12. 12 plus 2 is 14. The answer is 14 over 3. 3 times 3 here is 9. 9 plus 2 is 11. The answer is 11 over 3. This one, 6 times 10 is 60, plus 5 here is 65 over 5. Then over here with the year 6 questions, we've got 4 and 2/5, so 5 times 4 is 20, plus 2 more is 22 over 5. 8 times 9 is 72. If you had to write that down, that's fine. 8 times 9 is 72, plus 3 more is 75 over 9. And this one over here is 20 times 12. 20 times 12. Okay, so that should be 240, plus 3 more should be 243 over 12. I hope you've understood that. If you haven't understood it, I'm happy for you to go back, pause, re-watch this again. If you haven't understood it, please just comment below that you didn't understand it, and we'll go through it a bit more, okay? I wrote an extension question there just to see how everyone else would go. I don't know if I've solved this yet, so we'll see. It will test me a little bit, but we'll see how we go. If I try my mad strategy, I'm going to multiply there, add there, keep the denominator the same there, and I'm going to go against my better judgment and do algorithm here. Okay, 22 times 5. 2 times 5 is 10. 5 times 2 is 10, plus the 1 is 11. Put the 0 down here. 4 times 2 is 8. 4 times 2 is 8. My answer is 990. So if I write 990 plus 32, the answer becomes 1022 over 45. I didn't even tell you guys to pause it. I'm hopeless. Anyway, hopefully you paused it and had to go over it before I did. But if you didn't, hopefully that made a bit of sense to you, okay? Oh, yep, that was my working out. So I'm hoping that made some sense to you. So today we went through what an improper fraction was. Nope, let's rub that out and try again. Let's try spelling like someone who understands the English language. All right, improper fractions are when the numerator is bigger than the denominator. A proper fraction where the numerator is smaller, and a mixed fraction when you have a whole number and a fraction. Now remember, when you got those, if you remember to get mad, you should be able to solve those ones pretty quickly. With proper fractions, you don't touch them as they are. And with this one, you see how many times does 2 go into 3? It goes in once. How many left over? 1. And the denominator stays the same. I hope this all made sense to you. If it didn't, as I said, please let me know because the feedback is going to be useful for future videos. Thanks.